Hi guys, I'm back with my lectures. This is Mr. Joseph, your chemistry teacher. Today's lecture is a continuation of our previous lecture on enthalpy change of hydration. We'll talk about enthalpy change of solution. We'll talk about lattice energy. So today we'll be looking at construction and use of what energy cycle involving what enthalpy change of solution, lattice energy, and enthalpy change of hydration. And we're going to carry out calculations involving the energy cycle where we'll calculate the enthalpy change of hydration, enthalpy change of solution, and lattice what and lattice enthalpy. So please, I want us to listen attentively because it's going to involve what carrying the calculation involving what energy cycle. With the help of the energy cycle, we're able to calculate the enthalpy change of solution, lattice energy, and enthalpy change of hydration. So we are looking at the relationship between enthalpy change of solution, enthalpy change of hydration, and lattice energy. And this can be done with the use of the enthalpy cycle. We can calculate the enthalpy change of solution or the enthalpy change of hydration or the lattice energy by constructing an enthalpy cycle and using the Hess's law. And the Hess's law states that the total enthalpy change in a chemical reaction is independent of the route that is taken, provided that the initial and the final conditions remains the same. So before us is an enthalpy cycle involving the lattice energy, enthalpy change of hydration, and enthalpy change of solution. So if you look at the enthalpy cycle, you will see that these are gaseous ions, and this is ionic solid. So from gaseous ion to ionic solid is the lattice energy, which is the enthalpy change when 1 mole of an ionic solid is formed from its gaseous ions under standard condition. Then from ionic solid to ions in aqueous solution, that is the enthalpy change of solution, which is the enthalpy change when 1 mole of an ionic solid is dissolved in sufficient water to form an infinitely dilute solution. Then from gaseous ions to ions in aqueous solution, that is the enthalpy change of hydration, which is the enthalpy change when 1 mole of a specific gaseous ion is dissolved in sufficient water to form an infinitely dilute solution. So from gaseous ions to ions in aqueous solution is the enthalpy change of hydration, which is the direct route, which is enthalpy change of hydration. Then from gaseous ion to ionic solid is the lattice energy, which are the indirect route. Then ionic solid to ions in solution, which is the enthalpy change of which is the enthalpy change of solution, which is the enthalpy change of solution. So the both of these are indirect route. So the lattice energy plus enthalpy change of solution is equal to indirect route, going by Hess's law, which states that the total enthalpy change is independent of the route taken. So if you using Hess's law, you say direct route is equal to indirect route. That means I have to erase this. That means enthalpy change of hydration, which is the direct route, is equal to lattice enthalpy plus enthalpy change of enthalpy change of solution, which is the so with this we can calculate the lattice energy or the enthalpy change of solution or the enthalpy change of hydration. So before us is a work examples. Let's consider some examples. Now if you look at what we have here, we are asked determine the enthalpy change of solution of sodium fluoride using the following data. You are given the enthalpy change of you are given the lattice energy, you are given the enthalpy change of hydration of sodium ion, you are given the enthalpy change of hydration of fluoride ion, you are given the lattice energy, enthalpy change of hydration of sodium ion, enthalpy change of hydration of fluoride ion. So you are asked to calculate the enthalpy change of solution of sodium fluoride using the following data. So the first thing you have to do is to draw the enthalpy cycle. Yeah, you have to draw the cycle. So these are the gaseous ion, which is sodium ion and fluoride ion. This is the ionic solid. So from this point to this point is the lattice energy, just as I've explained in the previous slide. Then this is the ions in aqueous solution, ions in aqueous what? Aqueous solution. So you have to calculate the enthalpy change of solution. You are given the lattice energy. You are given the enthalpy change of hydration of sodium ion. You are given the enthalpy change of hydration of what? Fluoride ion. So all you need to do is to make enthalpy change of solution the subject of the formula, and you calculate. So it's as simple as what? A, B, C. So please, I will just listen attentively as to what? As we proceed. So going by the formula, enthalpy change of hydration is equal to lattice enthalpy plus what? Enthalpy change of what? Enthalpy change of solution. So if you look at what we have here, lattice enthalpy, lattice energy plus enthalpy change of solution is equal to enthalpy change of hydration. So making enthalpy change of solution the subject of the formula. So we'll have what? Enthalpy change of solution is equal to enthalpy change of hydration minus what? The lattice enthalpy. So the enthalpy change of solution is equal to what? This is the enthalpy change of hydration of sodium ion, enthalpy change of hydration of what? Fluoride ion minus what? The lattice what? Lattice energy. So by the time you do the mathematics, minus 406 plus minus 40 plus minus 506 minus minus 906. So you have what? Minus 912 plus 902. So therefore the enthalpy change of solution is equal to minus 10 watt kilojoule watt per mole. So the enthalpy change of solution is negative, which is an indication that the ionic solid sodium fluoride is soluble what? Is soluble in water. So it's as simple as what? As ABC. All you just need to do is to handle the formula, manipulate the formula, and make what you are asked to calculate the subject of what? The subject of the formula. So before us is a typical examination question. So what is meant by the term standard enthalpy change of what? Hydration. So the standard enthalpy change of hydration, please take note of what standard enthalpy change of hydration. It is the enthalpy change when 1 mole of a specified gaseous ion is dissolved in what? Sufficient water to form a very dilute solution under standard conditions. Take note of the word under standard conditions for you to get your full mark. So standard enthalpy change of hydration is the enthalpy change when 1 mole of a specified gaseous ion is dissolved in sufficient water to form a very what? Dilute solution. Or it can be defined as the enthalpy change when 1 mole of a gaseous ion is dissolved in excess water to form what? An infinitely dilute solution under what? Under standard what? Conditions. So that is what is meant by the term standard enthalpy change of hydration. Now let's go to the next question. Use the following data to calculate the lattice energy of calcium nitrate. You may find it helpful to construct an energy what? Cycle. You are given the enthalpy change of hydration of calcium ion, enthalpy change of hydration of nitrate ion, enthalpy change of solution for calcium what? Nitrate. So you have to calculate the lattice what? Lattice energy. So you might find it helpful to construct an energy what? Cycle. Let's just construct the energy cycle, then we calculate what? The lattice what? The lattice energy. So for the energy cycle, so you have calcium ion, which is gas, then plus nitrate ion, gas. So you have calcium nitrate, solid. So this is the lattice energy. Then from this, you have ions in aqueous solution, which is calcium ion aqueous, nitrate ion aqueous, then this is the enthalpy change of solution. This is the enthalpy change of hydration of calcium ion. This is the enthalpy change of hydration of nitrate ion. So you multiply it by 2. So this is the enthalpy what? Cycle. This is the energy cycle. The enthalpy what? Cycle. So from here, you can calculate what? You can calculate the lattice energy. So remember, lattice energy plus enthalpy change of solution is equal to enthalpy change of what? hydration. So make lattice energy the subject of the formula. So the lattice energy will equal to what? Enthalpy change of hydration of calcium plus enthalpy change of hydration of nitrite ion 2 times nitrite ion minus what? Enthalpy change of solution. The enthalpy change of what? Solution. So this is the lattice energy, which is equal to enthalpy change of hydration plus enthalpy change of hydration of calcium ion plus enthalpy change of hydration of what? Nitrite ion minus enthalpy change of what? Solution. So I have to erase this so that I can solve. There will be space for me to solve. So lattice enthalpy so enthalpy change of hydration of calcium ion is minus 1650 plus 2 bracket what? Enthalpy change of hydration of nitrate ion, which is minus 314 minus enthalpy change of solution, which is bracket what? Minus 19. So I'm to use my calculator now. So use your calculator. Minus 1650 minus 2 times 314. I think you have minus 628 minus times minus plus. So you have minus 1650 minus 628 plus 19, which will now be equal to what? Minus 2259 kilojoule per mole. So as you can see, it's as simple as what? ABC. So all you have to do is just to apply the formula, make whatever value you are asked to calculate the subject of the formula, and you put in the what? Put in the values. So it's as simple as ABC. Please attempt as many questions as possible. If you have any challenge, any difficulty, please feel free to reach out to me. I'm Mr. Joseph, a chemistry teacher. I'm always there for you. So solve as many questions as possible for you to what? For you to perfect, the calculation. So please feel free to reach out to me once you encounter any difficulty. I'm always there for you. So we'll continue as we proceed with other questions. I'll be giving you other questions for you to solve. Attempt as many questions as possible. So considering how far we've gone and based on what we've done, I'll be leaving this task for you. So this is a task before us. Please draw an enthalpy cycle to calculate the enthalpy of hydration of magnesium ions when magnesium chloride dissolves in water. So if you have paid attention to the lecture, I think you should be able to attempt this question. So just draw an enthalpy cycle to calculate the enthalpy of hydration of magnesium ion when magnesium chloride dissolves in water. Then the B part is calculate the enthalpy change of hydration, calculate the enthalpy of hydration of magnesium ions, given that what the lattice energy is minus 2592, the enthalpy change of solution is minus 55 kilojoule per mole, the enthalpy change of hydration of the chloride ion is minus 364. So you have to calculate the enthalpy of hydration of what? Magnesium ion. So it's as simple as ABC. Just make use of the formula, attempt as many questions as possible, and if you encounter any difficulty or if you face any difficulty while trying to solve the equation, please feel free to reach me. I'm always there for you. Reach out to me. I'm Mr. Joseph, your chemistry teacher. I'm always there for you to help you. So please attempt these questions and solve as many questions as possible. So just like the enthalpy cycle, we can represent the lattice energy, enthalpy change of hydration, and enthalpy change of solution using the energy level diagram. So we have to use the energy level diagram. As you can see with the diagram before us, you can see that some of the arrows are going down and while some of the arrows are going up. So we need to consider, the processes that is involved, whether it's an exothermic process or an endothermic process. Like lattice energy is what is exothermic, so you can see the arrow goes down. So if the process is an exothermic process, the arrow will move down. If the process is an endothermic process, the arrow will move up. So we just want to use this to represent the enthalpy cycle using the energy level diagram. So what we have here, you can see gaseous ions to ionic lattice. So that is the lattice energy or the lattice enthalpy. So you can see the arrow going there because lattice energy is an exothermic process. Then this is hydration from gaseous ion to aqueous ion. This is the hydration. You can see the arrow going down. Hydration enthalpy change of hydration is always exothermic. So the arrow is going down. Then, this is the enthalpy change of solution, ionic lattice into aqueous ion. So this is the enthalpy change of solution. The enthalpy change of solution here. The enthalpy change of solution can be exothermic or endothermic. Here in this cycle, it is an endothermic process. So you can see the arrow moving upward. So that's an indication that is an endothermic process. It can be an exothermic process. You see the arrow moving downward. So this is how we use we use the energy level diagram, to represent just the enthalpy to state the relationship between lattice energy, enthalpy change of solution, and enthalpy change of hydration, just like the enthalpy cycle. And we come up with the lattice enthalpy plus enthalpy change of solution is equal to the hydration enthalpy. So this is the energy level diagram of sodium fluoride as an ionic solid. So what we have here is the gaseous ion, sodium ion, fluoride ion. Then this is the ionic solid. So from gaseous ion to ionic solid, this is the lattice energy, which is an exothermic process. You can see the arrow moving downward. Then sodium fluoride to sodium fluoride solid to sodium fluoride aqueous. This is the enthalpy change of solution. You can see the arrow moving down. So enthalpy change of solution of sodium fluoride is an exothermic process. So the arrow moves down, which is that means the value of the enthalpy change of solution of sodium fluoride is negative. Then from gaseous ion to the ionic solid in aqueous solution, that is the enthalpy change of hydration. So this is the enthalpy change of hydration of sodium ion. This is the enthalpy change of hydration of fluoride ion. So you have to calculate the enthalpy change of solution. So enthalpy change of solution of sodium fluoride will be equal to enthalpy change of hydration of sodium ion plus enthalpy change of hydration of fluoride ion minus minus the lattice energy of sodium fluoride. So the enthalpy change of solution of sodium fluoride will be equal to So let me erase this so that I will have enough space. So it will be equal to enthalpy change of hydration of sodium ion is minus 406 plus bracket enthalpy change of solution of fluoride, hydration of fluoride ion is minus 506. Then lattice energy is minus bracket 902. So this is 406. So the enthalpy change of solution will equal to minus 406 Plus times minus is minus. Minus 5 O6 plus what? Minus times minus plus 90 what? 902. So if we are to calculate, so let me use my calculator now. So 406 minus 406 minus 506 okay, minus 406 minus 506 plus 902, which is equal to minus 10. So enthalpy change of solution of sodium fluoride is equal to minus 10 kilojoule per mole. So you can see that the enthalpy change of solution is what? Is negative. So it's an exothermic process. So that means sodium fluoride is soluble in water. So you can see that's why the arrow moves downward on the energy level energy level diagram. So it's as simple as ABC. So just attempt as many questions as possible and reach out to me for any difficulty. I'm Mr. Joseph, your chemistry teacher. So before us is a typical examination question for us to attempt. The diagram shows the enthalpy changes when sodium chloride is dissolved in water. So you are asked to name the enthalpy changes labeled A, B, and C. So please attempt these questions and attempt as many questions as possible. And feel free to reach out to me. I'm Mr. Joseph, your chemistry teacher. Please subscribe to my YouTube channel, comment, go to the comment section and drop your comment, like, share, and reach out to me if you have any difficulty. I'm always there for you. I'm Mr. Joseph, your chemistry teacher. Mr. Joe, your chemistry teacher.